Hi, another theory video, but something came to me today and I think I had to show it to you guys. Um, it concerns the issue of A equals 440 versus A equals 432 hertz. And I discovered the math behind it. And I don't want to get into much of the debate about which one of those two is right, even though I choose the 432 myself, but I don't want to get into that. And I don't want to get into the fact whether the debate is even matters or not. There's that debate too. I don't want to get into that debate either. But I just want to show where the number 432 comes versus the 440 and some of the math behind it. So first of all, middle C happens to be 256 hertz. I don't know exactly why they chose that, but I do know what that number is mathematically. So let's go into that real quickly. First, 256 hertz. First of all, 256 is 2 to the 8th power, but 8 is 2 to the 3rd power. So start with how do you get 8? Well, 2 to the third power is 2 times 2 times 2, and that's equal to 8. Okay, and then 2 to the 8th power, that looks like infinity. I mean to make that an 8. 2 to the 8th power is 2 times 2 times, let's start down here. 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6 times 2 times 2. So 1, 2, 3, 4, 5, 6, 7, 8. And if you work that math out, 2 times 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 2 is equal to 256. That's and 256 hertz. Hertz just means cycles per second. So all that means is that so far you have that middle C, I'll just call it C here, equals 256 hertz. That's just vibrations per second. Now here's that's just the background. Now, what about the A part? Well, the A is supposed to be the A up that is above middle C, which is the A above 256 hertz. And remember I told you that when you add intervals linearly on an instrument, you multiply the frequencies in math. So if you want to know how to get from C to the A above middle C, which is what the A that's in question, you say that what is the frequency ratio of the interval that's represented by that, and then multiply it out and see what it is in math form. So you'll see that C to A is equal to C to G, then plus G to A. I'm going to do it in two parts. So if you go from C to G, that's a perfect fifth. That's 7 half steps. And then if you go from G to A, that's 2 half steps, and that would be a major 6 above the C. So because a major 6 is a perfect fifth plus a whole step. So we're going to take the interval ratio of a perfect fifth, multiply that by C, and then multiply the whole thing, multiply that by the frequency ratio of a whole step or 2 half steps, because that's going to add that extra from G to A. There's two parts to that. So I'm going to start with 256, and then I'm going to go what is the interval ratio of G, and then what from C to G, and then from G to A, and multiply both of those two things. So so from C to G is a perfect fifth, and that's 3 over 2. So far to go from the C to the G, you multiply 256 times 3 over 2. So that would be 256 times 3 over 2. I'm just gonna do it with a calculator right here because I didn't plan. I don't have any of this prepared. I'm just gonna do it by the seat of my pants here. So I have a calculator. First, let's do 256 times 3. So 256 times 3 equals, that is 768. Then I'm going to divide that by 2. Divided by 2 equals 384. I write a 4 here. I can't write a 4, dude. Okay, 384. That would be the G above middle C. But that hasn't taken into account the final interval of the whole step, because you've got to start with 384 and add and multiply that by the ratio of a whole step to get from the G to the A. So let's start with the G is 384. The G above middle C. Now, you got to go from G to A. You have to add the ratio of a whole step. What's a whole step? Well, this is hard, but a whole step is 2 perfect fifths minus an octave, because 2 perfect fifths is a major ninth, and then octave below major ninth is a major second, which is 2 half steps. So first, what is the integral ratio of a fifth? And to get 2 fifths, which a major ninth is, you multiply the ratio of a fifth times itself. So a fifth is 3 over 2. Now multiply by the ratio of 3 over 2, which is another fifth. That will give you a major ninth ratio. And that is 3 times 3 is 9, and then 2 times 2 is 4. So a major ninth is a ratio of 9/4. But you got to go an octave below that to get a major second, because a major ninth is a major second plus an octave. So how do you go down an octave? Well, to go up an octave, you multiply by 2. So down an octave, you divide by 2 or multiply by 1/2. So you're going to take 9/4 times 1/2, and that is equal to 9/8. So 9/8 is the frequency ratio of a whole step. So to get the frequency ratio of the A above the G, which is above the middle C, I'm going to take the 384, which is the G is, and I'm going to multiply by the ratio, the ratio of a whole step, which is 9/8. I just showed that. Okay, or I say times. I'll say times 9/8. Okay, so let's do that in 2 parts. I have a calculator right here. Hopefully you can see this times thing right here. I have a calculator right here. I haven't. I'm just going with the flow here. So what's 384 times, first 384 times 9 is 3456. So that's the 384 times 9, but you got to divide by the 8. So 3456 divided by 8. I'm going to do it on my calculator here, is equal to 432. I can't write a 4. 432. So if middle C is 256 hertz, which we get from the fact that 256 is 2 to the 8th power, I'm not sure how that relates exactly, then the A above middle C is 432 hertz, not 440. So that's very curious and interesting. The debate goes on. One side, I even heard it cause World War II, because the one side of this is the people that choose science, and that's the Allies, and the people that chose the magic and the mystical were the Axis powers. I'm not even sure which side represents which number and which side I would choose, or which side is right or wrong, whatever. That's all debatable. And then there's another side that says the debate isn't even relevant. And there's all these experts that say that. Well, that doesn't make it not true, just because in fact, a bunch of experts say that it's not true. Sometimes that just to cover up the fact that it might be true, but whatever. Anyway, so what I have heard is that some German dude that I don't even know the name of changed it to 440 instead of 432 in the World War II era. And the reason I think 440 was chosen is because it's a simple number. It has two numbers that are repeated and a 0, so it's easy to remember. And it's close enough to A442 to be off, but not so far off that everyone's going to notice. So if you wanted to cause a little confusion and mess with the universe or whatever, you could throw it off just a little bit, but not too much. If you throw off, so no one will know, but yet it'll have its effect. And I think 440 would be a good choice because it's just a little higher than 432, but not so high that it makes a big difference and everyone's going to know. Anyway, take care. Love you guys. Bye-bye.